say aye or speak up. Else we'll consider the motion carried. All right, so that is so carried. So I'll get together with Al and see how we can just have it open so that we don't have to worry about members trying to log on. I think it's probably the best way to handle that, Greg, don't you think?
Yeah, we don't hand out the little cards that have the password and club membership on it anymore. But and also, I think, Charlie, you get the emails that come from that address?
Yes.
The Gmail?
Yes.
Okay.
I sent you the password for, or the password for that, didn't I?
Yep.
Yeah, you did.
Yep.
So,
okay.
And I think, Bryce, we should just also forward it to tell them to, is the groups IO on that main page?
Yes, that's the group's IO page. Yeah, that's the main page. Anyone can, once they get to groups IO, you just sign.
No. On the w0cxx.us.
I have not updated, or I need to have Al update that main page to create a link to the group's IO page. Yes.
Yep. And then take the password out. That's what I think we talked about before. So.
Yep. Okay. I'll follow up with Al on that then. Jot myself a note real quick.
Al will be joining us shortly. He got hung up on the way home, and he'll be jumping on here as soon as he can.
Okay.
I'll also make a note of just for the general membership's knowledge. On one hand, this is banking. On the other hand, this is just better for everyone's knowledge. We are the Rockwell Collins Amateur Radio Club. I understand that over my entire lifetime, we have been called the Collins Amateur Radio Club. But for anything that needs to be officially documented, officially approved, might potentially go in front of a bank or other organization that cares about that type of information. Rockwell Collins Amateur Radio Club is the name that we must use.
Hey, Chris, do you know if that will end up changing to Collins Aerospace?
So here's the deal. Here's the deal with that. We have a branding problem at our company, number one. Where there's a bunch of different comments about whether in our own documentation in our company, whether we are going to Collins Aerospace or not. The fact of the matter is as follows. The Rockwell Collins Clubs and Leagues, which is the EIN or the employer identification number or company/club account social security number, is like Rockwell Collins is the legal entity on all of our paperwork. It's slowly beginning to bleed through, but unless we want to do, like, there's a couple options, as I mentioned to you privately, but for the entire club's knowledge, we can go out and go get a doing business as a DBA with the state of Iowa. And then at that point, we can be Rockwell Collins Amateur Radio Club doing business as the Collins Amateur Radio Club. If that's something that the club would want, I would desire a club member not on the board of directors to come up and join and be a part of like a financial committee with Dave Kreit and Adam and volunteer to go through that process. The other thing that we could do is we could go apply for our own EIN, which would then become, instead of us being like piggybacking on the clubs and leagues social security number, which, trust me, this is very cringy when you're looking at the IRS and explaining this to them. We could have our own functional social security number. I don't believe we need that. I'm going through the work right now of getting our beloved Collins Credit Union to get some paperwork corrected from 2020. The IRS only looks at the first 4 letters of that EIN information to match your bank account with your social security number, if you will. So I don't foresee that being something that's going to happen in any speedy amount of time. That's a long way of explaining. I don't think it's going to be changing for the foreseeable future.
Okay. Yeah, well, it sounds like it's a lot of extra work that may not necessarily be worth it at this point.
I'm completely, again, I would be looking for a volunteer. I would not be volunteering an officer of the club to be working through that necessarily, but they would want they would need help.
Okay.
But yeah.
May I offer a little perspective from the treasurer?
Sure.
Yeah, Christopher, thank you for that. I am just completely aligned. And I think the direction that you seem to be recommending is in line with the direction that the company has taken in most matters of human resources and contracting with customers and suppliers and such, which is anything formal and official, legal documents, et cetera. They still say Rockwell Collins. I think my W-2 from the company still says Rockwell Collins on it. I'm an active employee. And anything that's quote informal, website, branding, flyers, business cards, like anything we do with the club, I can envision us having banners at field day or whatever, can say whatever we want. We can call it Collins Amateur Radio Club. Signs in the shack can say Collins Amateur Radio Club. But our bank statements, I guess I'm just going to support your recommendation that either leave it as is or ask for a volunteer to run the whole thing, because it's an involved process to change. And from the treasurer's perspective, not worth doing, at least my current view.
Yeah. And also note for general membership, for signing up for paying your dues, even though, say, Adam doesn't necessarily have the banking stuff completely worked out. Like, I haven't gotten that completely fixed up yet. Adam can collect your dues. He is in full control of that and has all the resources to be able to help you with your dues related questions.
I've got a quick comment.
Go ahead.
Yeah, I think our FCC license for those club stations here say Collins Amateur Radio Club, but are we going to have a little conflict there, or do we need to change those licenses? And then the other interesting thing is the guys down in Richardson, I think it was a couple of years ago, they got rid of their W5ROK call and went to N5CXX. And I just looked on QRZ and they're listed as the Collins Amateur Radio Club also. So there may be some overlap here that has to be dealt with.
Yeah. And I think that's typically what we've done in the past. We probably need to go make sure everything's up to date with different organizations, but yeah.
Yep. So on the FCC site, W0CXX is listed as Collins Amateur Radio Club. And if I were to do a search for N0CXX, I think it comes up as actually Rockwell Collins Amateur Radio Club. Yep, it does. So N0CXX apparently is listed as Rockwell Collins Amateur Radio Club, and W0CXX is listed as Collins Amateur Radio Club. And
yeah, I think I know why too. I don't believe the FCC will assign two call signs to the same club. And I think that's why we jiffled it when we created N0
Yeah.
CXX.
Sounds
Yep.
like a fine reason. Yeah.
And
Well,
now they won't
and-
let one person be the club station for two different club calls. So go
What-
figure, Rod.
Well, it's more specific than that, Chris. When I was digging into that, when we were switching over, because Mike Heineck had had both call signs as the trustee, and when we switched them when you were trying to switch them over to or Chris to you, it only accepted the N0CXX application and rejected the W0CXX, because there's a rule now that because these are actually vanity call signs versus a call sign that the FCC would have issued, there's this extra level of, nope, you can't, or extra rule that, if you're applying for vanity call signs, only one person from a club can have that vanity, be the trustee of that call sign. So we may have at one point, got around, like you said, Rod, got around having a vanity call for the club by basically naming two different club names. But now someone then figured out, well, you're really the same club, and so you can't have two vanity calls and the same trustee for that. So that's why that got kind of shifted that way.
And that strikes me as some things I heard from as a little child, maybe, of people being very, I'm going to get all of these little random vanity calls and have like 10 different personas on the air. So maybe that's why they're cracking down on that. But
Yeah.
Yeah. There was a case, I think what started that, some guy created 23 little clubs, made himself the trustee of all of them, and he had 23 call signs. And when the FCC uncovered that, that's when these rules all got changed.
Oh, okay. Yeah, playing a little fishy game there. So that's unfortunate. All right. Any other discussion on this? Okay.
Next slide.
Yes. Secretary's report. I know we had some minutes, but I don't know if I don't think they actually got sent out. So I'm not quite sure how to handle this.
so typically in the past with Dad not keeping secretary's minutes, Dad kept the bar really low for not sending those out. But if we want, if you and George and Adam decide that that's maybe we want to start having minutes get approved and sent out as part of the newsletter, we can change that. That's all up to you guys.
Okay, so from a transparency perspective, I know George has set up kind of a monthly board meeting just for the officers to kind of get together and chit chat. And so I think we're probably looking at trying to capture some level of minutes for that. And can you guys still hear me?
Yes.
Okay. I just saw a circle go on my mouse, and so I wasn't sure if it got hung or not. Well, it'll probably take some time, but we probably will at some point get a little bit more formal about taking those minutes and then trying to quote unquote publish those for the membership to see what the board has been discussing. And and by all means, if people are interested in attending those, certainly reach out to any of the officers and we can certainly add you to the invite on that. So that's probably where that'll eventually end up. I know, Chris, you from a treasurer's report, I know you were trying to get stuff set up, but I know with this transition, I don't know if you had anything further.
The numbers haven't really changed from last quarter. I would say your guys' thoughts about adding those minutes and even publishing them. I know it saved our butts with the IRS in 2020/1919 or 2019 was having video recording. And I know with Zoom, you can get that like kicked up to the cloud and then stored back down. But even just having written minutes is good. That having that out on the website, easily accessible for any treasurer or financial officer to be able to go back and show a bank or anybody detailed stuff is going to be good in the long run, I think. Just because I'm noticing some rules changing on the banking side. I think right now the major, instead of 9/11 being the thing that's driving it, I think it's now child trafficking and human trafficking. And rules related to that are beginning to affect how the banking industry is working in the past like couple months.
Yep. I did. Yeah.
Yeah. Okay, I like that. I know Zoom has. Yeah, like luckily when it saved our butts, it was still pre-COVID, so it was in-person meetings and whatnot. But yeah, either way, if we can just have them, if it's easy for someone to do, that's all that matters. But that's all I have right now.
I'd certainly be for that because at a minimum, we can record the meetings so that those members that weren't able to attend at the time, they could go back and kind of catch up on what they missed. So I'd be for that. I didn't get around to actually recording today's meeting, but so if someone wants to actually capture at least the presentation, that would be great. Okay, that'd be awesome. Thanks. Okay, any other discussion, information on either secretaries or treasurer's report? Adam, you have anything in particular input?
Keep it pretty simple and high level beyond what Christopher shared with respect to us being in good shape. I'm looking forward to seeing the bank accounts and understanding that quantitatively. And part of the reason I'm looking forward to that is I trust that we're in really good shape financially for a club and league. And I know that we have the club voted to move out on an N0CXX kind of reconstruction and repurposing last year in one of the meetings. And so I'm looking forward to supporting that, i.e. From my perspective, writing the checks or paying the bills as soon as people are ready to move out on that, as well as the other HF activities that I think are going to come up in new business field day and such. And so looking forward to getting access to the bank accounts, looking forward to paying for those improvements so the club can, kind of thrive and continue. I think from a dues perspective, I did get one inquiry that the board got an inquiry about how do I pay dues this week? And so I'll reiterate here the answer that we answered to that individual. There's the system that was used at least last year and possibly before that, Shutter Up, the online system continues to exist. It works well. I have access and I can see in the account right now, 37 people have paid dues for 2022. It's the fall of 21, spring of 22. And so we'll plan to do the same in this coming year in September. I think it is September. We have a collection meeting, and I think the board is leaning toward having that in person again, although you can pay your dues anytime around that time online, but we'd like to get together and just see each other and share some food and collect dues for those who are so inclined to pay there on site. That's it for me, unless you have any questions, Bryce.
Cool, thanks.
Yep.
Kind of the segue a little bit on what Adam talked about. The board did talk about going ahead and ordering some antennas. So the primary discussion was making the N0CXX station more of a VHF, UHF with some HF capability, and then with W0CXX mainly being at the HF setup, though with a little bit of VHF, UHF capability as well. So I know we've talked about, I think we can go ahead and order the antennas and stuff that we've talked about in the past, and hopefully here in a couple of months, we can actually have an antenna raising party and have that back up on the air.
Can I add to that?
Yep,
Bryce?
go ahead.
We really need to kind of put a stuck E to this. I mean, I don't know who has availability, but if somebody's interested in doing this, we'll certainly, I'll certainly support you. Charlie will support you, I'm sure. We'll help you get that, help you get up on the roof, get access, take some survey, start looking at what we need to do, and stuff like that. But we need somebody to be the point person on it. So is there anybody that wants to volunteer on the N0CXX repair? I know it might take all summer to get this done, but the weather's good now, and we should try to start early then versus wait until the fall. Do we have any volunteers?
I know we have. I know certainly we have a voluntold from last year, and that would have been Danny Rhodes. But again, I'm a big proponent of ixnaying any sort of officer for life type treatment. So volunteers are much better.
Yes. We did have a list of what we wanted to do. We certainly can set up a meeting, but basically collecting the antennas, we'll have to coordinate with somebody to take the old antennas down. So anyways, we're looking for a volunteer if somebody's willing to do that. I'm a little busy this year, so I can't take on another antenna build and organize effort again, but I'm certainly willing to help. So we're just looking for a name. Think about it. If you have a desire, contact me or contact Bryce or contact George, and we'll sit down and work with you. I've sent a note to Danny. I don't know if Danny's on, but he hasn't responded to me. And I've sent a couple notes to him. So I'll talk to him again and see if he's really interested in doing it. But that might be something that's, he's not in his wheelhouse there, Christopher. So.
And also on that note, then Amon, if he is not really feeling like he's available to be, say, a shack manager, having like that Stucky there is someone who gets to take pride in the shack and enjoys that. And that would be also a good thing to have for main plant. Like I'm currently willing to act as that, and will, even if I'm not, I'm happy to be the liaison with Lab 13. Yeah, volunteers are always welcome.
Well, we'll talk some more. We'll talk some more, Christopher, you and I. The first thing that we really, like Adam said, we need to purchase the stuff because we know what's up there isn't going to work and we have to take it down. So anyways, we'll probably send out another invite to the club membership to see if we'll set up a separate meeting and have a full-on discussion about it and try to find somebody that might be willing to help us. Yes. Yep.
Yeah.
Yep.
No, the antennas were in there too. We listed all the antennas. It was in a newsletter too, I think. So we had all the antennas, we had everything that we were gonna do, so.
Yeah, I think it was in either the last or the previous, prior to the last one was in the newsletter, so.
The idea,
What,
yeah, in general, the idea is to create a hex beam and then a VHF UHF station, so for a weak signal. And then we do have some other work like D-Star and some other stuff that we have to take care of. But there's a lot of bent parts up there, as Charlie's pointed out. So. Charlie has a lot of pictures already. I think Charlie can show you what's broken and bad. So.
Yeah, he did a pretty good job with that as to what got damaged. Looks like
Looks like there was something at main plant that lifted the air because the 2 meter didn't get hammered down there, but it certainly did on this one. On the north station.
Yep. I think we can go on.
Yeah.
Okay. Yeah, so just let us know. And it's mainly, as Greg mentioned, someone that just kind of organized stuff for that. Field day. So at the last CVARC meeting, it sounds like they are deferring to Collins in terms of any field day activities within the area. I am probably going to go ahead and take the lead on trying to at least figure out where we could have it on the Collins site. I am going to be out that weekend though, so hopefully at least get things organized in such a manner that we can set up in some antennas and what have you. So I'll be kind of taking that and letting the membership know as to how things are going with that. Greg, did you have any particular things on the EME?
Well, I do have a few updates. I mean, we have talked about setting up a temporary EME site so that people could get on the air and try EME. But it's not as easy to do it in town. And you have to have a nice quiet location. But there's another thing that's brewing in the background. At the Palisades Kepler Observatory, we may have the opportunity to get one of the dishes off of the University of Iowa. And the Palisades Kepler group has asked us to, informally help them get their dish, radio astronomy dish, up and running. So Mark Coveland, myself, and Jim Hansen have been helping with this. And so the interest there is probably to do something with just reading the hydrogen line and doing some, some of that radio astronomy. So this is a long-term project. Looks like Palisade Kepler group will probably mount the telescope out there. They have a site or a location at their site. They'll transport the equipment back here. It does have all the radio astronomy equipment with it that we'll get with it. And we'll probably have to help the Palisades group kind of get it working. That's what our commitment has been to it. So stay tuned. There's some interesting stuff going to happen in that area. I suspect towards the later part of the summer. So,
Greg, I'm a member of this Collins Amateur Astronomers, and the latest I've seen is they're looking with the Lynn County, whatever the guys that do the maintenance, to put down some piers for the antenna. Now, the work to get it off the roof and get it out there, that's another story, but it's not certainly going to be ready by field day. The other thing I should point out is that it has an elevation. adjustment, but there's no azimuth on that dish. So it's good for radio astronomy, but probably not very good for EME.
Right, right. I understand. And that the different, I'm just trying to say that there's some other opportunities to do some stuff. So, and if we get EME up and running again another time, out, I can't, Rod, what is the farm that we'll go to all the time?
Oh, it's Heinz's farm, NR0X.
Yeah, so we can probably try to make it a little bit more public and get you guys out there to do the ME when we do it there. But it's pretty tough right now I don't know if Lance is getting something set up again, and I don't know what we're going to do, but again, we can certainly get people on 6 meters and 2, so for EME at some point.
Yeah, Lance is going out to another French island in October, I think it is. You can find it on his website, W7GJ.
Yeah, so that's kind of what we kind of focus on, trying to go out when Lance is out. So that's all I have for EME.
Okay, thanks, Greg. And just as a reminder, Saturday, May 14th is the Junk in the Trunk at the main plant parking lot. So without further ado.
Yeah, I just want to point out, we went through all the people, we went through the guard station and security and the legal folks. They have no problem with us having junk in the trunk. So.
Yeah, last I saw on that, Greg, was someone was they were putting some form. I need to follow up with Barb on that. Is someone in thing, but I haven't heard from her. So, but that was just last week. So,
right.
Greg, you want to go ahead and make introductions then on our program?
Well, certainly I can give kudos to Dave. Dave has helped me in a lot of different little things. It's always interesting. He has a good general background in amateur radio. He helped me fix my Collins radio. He went down and picked it up. Where'd you pick it up in? Tennessee? No.
Indiana.
Tennessee? Indiana. So, yeah. So anyways, I'll let you go and take control.
Okay, Greg, can you hear me? I guess that's the first step.
Yeah, you're a little light, but I think we can hear you.
Okay.
And if everybody can mute, then Dave will have full control.
Okay. My name is Dave Graham. I'm WA0YDO. Been an amateur radio operator for about 50 years. Spent about 41 years working for Collins, doing all sorts of different things. And Barry Bulow knows that I've been messing around with Arduino Nanos for several years. And he told me that was too small a computer anymore, and that I had to learn something about the ESP32. And so I got a hold of some of those and decided that my winter project this year would be learning how to do something with it. And as a note, this presentation is going to be available on a website if anybody wants to see it. I guess you're recording it so somebody can just listen to me, but if they want to look at the slides themselves, it's going to be available on this website for, I think, 3 weeks. So we'll proceed with the presentation. And I'm going to talk a little bit about my very specific project. I'm also going to do a little advertising for the ESP32. And then I'll go back and do some more details and whatever amount of time there is left to talk about some specifics that may be too detailed for people who aren't real interested in it. But the reason for talking about the details is to say that it's a finite number of details, and it is possible to make the thing work. So the goals for this project, we wanted to get a CW filter to work with my S-line. I don't have the narrow crystal filter in my receiver. The S-line has the receiver audio come from the receiver, and the transmit side tone comes from the transmitter, various bits and a lot of wires to hook up the boxes. So this was a filter box to connect to the S-line. Make the S-line a CW transceiver. I also wanted to learn something about digital signal processing. I was associated with various digital signal processing programs during my career, but I never had to learn much about digital signal processing. So, and also then to learn the ESP32. As part of this project, I first did a get this going here. I first did an audio filter based on analog, and that was this card. Several hundred parts, and when I wanted to add a feature, I had to get the soldering iron out and add another little board. So that was part of the impetus to go digital. You can change things easier. So then I did a fixed frequency DFO for the 75S. Unfortunately, DigiKey has not been able to provide the little oscillators that I need. They're completely out for months. So that project's not ready to talk about. It's not really done. Then I did, in center here is a picture of for the DSP brass board. Took one of the analog circuit cards and put some mini board on top of it, put the ESP32 on. And then the third card is the signal processor, an audio signal processor based on the ESP32. So I wanted a nice narrowband receive capability, and of course, having a real crystal filter, a narrow crystal filter is better. You don't have the AGC problem, but I was able to get a couple of reasonably narrow filters in the surplus market and adapt those to work in the commons with some matching. It's not as smooth as a 200 hertz crystal filter, but it's pretty good. So I did the analog audio filtering, got all the cabling figured out. So I had an analog-based audio filter. And that's when I was talking to Barry, and he suggested that the ESP32 would be a good thing to learn. I also want to thank Bob Heinrichs for helping me review the presentation and get ready for this presentation. So this is a picture of the final board. This little gadget right here is the ESP32 itself. ESP32 is a processor, and we'll talk about the details of that. The next level up, and this is what you can buy off of Amazon. It's what they call a development board. And that holds the ESP32, a programming USB port, and some power supplies, so that it's a easy to use, hook it to your PC and program it, little processor. The development board will plug into one of those little white prototyping boards. The headers on it are 10th inch, so we'll plug into any board, or you can use 10th inch headers and stick it on your own circuit board. That's physically what you're looking at. It has two 32-bit, 240 megahertz cores, so that's a fair amount of processing power. It also has a little 8-bit processor that runs on almost no power. It's almost like an Arduino Nano that runs on micro power for something like a real-time clock or other data gathering. The board has a Wi-Fi Bluetooth radio on it, and that is not used in this project. That would be I don't have any of the little radio earphones to use with it. So I didn't need that. Has lots of different memory, lots of it. It has direct memory access, which we'll talk about just a little bit. It has two I2S buses, which are great for hooking up to audio accessories like analog to digital converters and digital. So we'll talk about those. It's got timers, it's got pulse width modulators, and it's got what they call an I/O matrix, which basically allows you to hook any of the internal peripherals to almost any of the pins that are brought out. So your hookup is extremely flexible, and that is also an advantage for a project like this. Got two internal, not particularly good analog to digital converters. They're not super linear, they're 10 bits. It's got two internal DACs that are 12 bits, which are pretty useful. The community has a lot of online documentation. Comes from China, and it's not very easy to understand. And we'll talk about that a little bit. But there are a lot of people out there in the world using it, and an awful lot of people putting out things on YouTube and GitHub. A lot of projects out there. So you can learn a lot about how to use the ESP32 on the internet. There's both an Arduino-based development environment available. For those people who've have spent some time with the Arduino processors, they're accustomed to using the Arduino development environment. That's pretty much available for ESP32. There's also an Eclipse-based development environment. And I did my project using that. It's probably not as popular as the Arduino, but the editor is fantastic, and a lot of other features in the Eclipse environment, which you folks may have used in, I know at least when I was using it, the HP, the Hewlett-Packard circuit analysis program ran in the Eclipse environment. I know Rockwell Science Center also built us some tools that worked in that environment, so that it may not be completely unknown. They put all sorts of extra parts on that development board that messed up a lot of the output pins to make it work with the camera. So that one was not good for digital audio. The second one I bought also didn't bring out pin 0. So third time was a charm. I let go for the new pin version that you can buy on Amazon for $11. Brings out all the IO. Reasonably well documented. Now, these two cores are really like two separate processors, except that they share a lot of the memory. So you can access memory from both cores. And a core is just like a processor. And if you start using the ESP32, software will probably end up all on core one. I'm not sure how easy it is in the Arduino environment to use both cores. People have made statements that you can't use both cores, but I believe that you actually can in either the Arduino environment or what they call the ESP IDF. In my project, I've got core one using 2 channels of audio. One channel comes from the receiver and one from the transmitter side tone. I've got 6 selectable bandwidths done with FIR filters. And then I put out 3 channels of audio, 2 headphone channels and a speaker channel. Developing some different kinds of nonlinear processing, which basically try to enhance my ability to hear the CW in the presence of noise. And the core one also interfaces to all the hardware, the front panel controls, indicators. I've got a meter. It does all the initialization of the hardware, and it also sends status messages to the PC when I'm debugging the software. I got all that working, and realized that I hadn't done anything with the other core, which is the one that is normally used to do Bluetooth stuff. And so I put a couple of fast Fourier transforms on there and send signals out to an oscilloscope as a display. So I got that core reasonably busy doing FFTs as fast as it can and formatting displays. Probably enough processing left there that I could send audio out Bluetooth to a set of wireless headphones, but I've not tried that yet. Here's a partial block diagram of what's going on inside. Bringing the receiver audio goes through kind of a riffing filter. There's a little bit of a riffing filter in analog hardware. This turns out I really didn't need that because the analog to digital converters oversample and really do, for all practical purposes, they do all the riffing filter you need. I have a bandpass filter, and also reduces the sample rate down, and a mixer down to I and Q. So this is almost like a direct conversion receiver with a input frequency of 750 hertz, and then I and Q down at the basically at DC. And they also do the narrow band low pass filtering. You can just call a bunch of different filters there, and whichever bandwidth you want. Then the next step is to upsample it back up to 12,000 samples a second. Unalias that and mix it back to audio. And to pick off in various places to pick signals off to go to displays. And then also send the audio out and send it out to the digital to analog converters. Can people hear me? Greg, are you hearing me all right?
Yeah.
And I'm not sure I know how to change that. Maybe I'll just get closer. Is that better?
Yeah, I think so.
Okay. Bandwidth wise for the filters, we've got 5 selectable bandwidths here that are reasonably narrow. If you run too narrow bandwidth, listening to a QSO where the guys aren't really netted very well, it can be too narrow. So, it's not too hard to build filters of different bandwidths with that. This is the what the brass board looks like, and this is the oscilloscope display. But these two different traces here, these are the FFTs. We actually have two different FFTs on the list. One is kind of the input audio signal, and the other is the output of the narrowband filter. The green trace here can either be a logarithmic amplitude display or a frequency display. It's selectable. One of the goals was to make this kind of simple, but since I didn't really know at the beginning of the project what all I do, I put lots of controls, and I bought a 5-pack of potentiometers and put a whole bunch of controls on the front panel. So I have a code practice oscillator in there. I can set the level of that. I can set the level of the side tone from the transmitter. I can select the bandwidth of the filter. This is just a wire out to feed the Collins S-line. Volume controls for the speaker and the headphone. And the expander, there's a couple of different ways of doing processing of the audio to make the CW signal stand out from the combination of CW and noise. I've covered that. Now I'm going to talk about how do you do digital audio and what makes the ESP32 support doing digital audio. Basically, the I2S buses are fairly simple digital audio buses that come from the entertainment world. This was originally invented for use with CDs to move the 44 kilobit kilo sample data for CDs. The IT buses in the ESP32 are very flexible. And what's important is the hardware inside the chip makes it so you can just directly hook to any one of the digital converters and digital analog converters that are designed to work on that bus. And they have, some of those chips have a bunch of different options. The ESP32 has all the options, and you mostly just set them all to the most default ratings that your hardware also supports. ESP32 also comes with what they call a real-time operating system. And we don't have to, I won't spend a lot of time about this, but they have all that real-time operating system has the features you need to do real-time things. You can assign tasks to whichever processor you want. And you can have a task stop for a given period of time, or you can have a task stop and restart at a fixed period of time after its previous start. And that's key for doing digital audio. You basically have to set your work up to be done periodically. And these features allow you to have your processor start working on audio samples exactly when you want it to. And in my case, it starts up and goes to work every 4 milliseconds. It processes the 48 samples that have come in the previous 4 milliseconds and outputs the next 4 milliseconds of output data. These are the commands in the real-time operating system that allow you to do that. These queues are what allow you to send data from one task in your program to another task, operating on another task. So the ESP32 has all that stuff. It might not be easy to figure out how to use it right off, but once you figure out how to do it, it's all easy. And the combination of things they put in there makes it very capable for doing. We'll cover that in some detail. So this the I2S bus takes up to five wires. Three of them are clocks. One's a bit clock, one's a word clock, which we call the left-right clock. And then the master clock is a pretty large multiple of the bit clock. And that gives the peripherals a clock to use to do the digital signal processing that's done out in the peripherals for anti-aliasing. It makes these peripherals very capable. Configure the I2S bus in the ESP32. We'll show how that's done. It's just putting in some constants, basically. Very flexible. You can run it at just about any frequency you want it to run. You can run it with any of the synchronizing modes that the industry has come up with. They're basically two synchronizing modes. You can select which one you want to use. The peripheral inside the ESP32 can operate in either the master mode or the slave mode. Since I'm using both buses, I actually have one serving as I'm using both peripherals. One is operating as the master, and all of the outside peripherals are all considered slaves. So we'll talk about how that gets set up. We'll just walk through it and show that it's not too awful difficult. When data is moved inside the ESP32 using direct memory access, so you don't really have to put a lot of effort into coding how data is stored and made available.
Is there any automatic lock between the two processors when you're doing that read and write?
The way that well, in some of the methods, yes, and others not. If you want to move data between the two processors, it's best to use what they call a queue. And those are
A what? A what? I didn't hear it.
It's called a queue.
Okay.
And well, first of all, both processors have access to almost all the memory. So you could have, if you were not careful, you could have the two processors end up poorly sharing locations in memory. You try not to do that. You try to discipline all of your movement of data between the two tasks, or multiple tasks that you might have. You try to use the internal queue, the queue features of the real-time operating system. That's the safest way to do it. That manages it for you so they can't do anything illegal. I've had luck in past in writing my own methods of doing queues. And that's also possible here because of the shared memory. But it's easy to use the queues that the operating system provides you. And we also have semaphores and other esoteric software things. But the queues are easy to use. one guy can shove data in, the other guy reads it out, and it just looks like a memory location. Very, very straightforward. And the DMA is the same way. You set it up, and when you want to get samples from the analog to digital converter, you just pull them off of the received queue. And when you want to send samples out to the digital to analog converter, you just write and send it, however many samples you want to send, just stick them in there. As long as you've got them done in the designed period of time, out they go and then they get played. So I have, I took the zero I2S peripheral and I made him a master. That puts out this high-speed clock, which in this particular implementation is 3.02 megahertz. It also generates the bit clock, the left-right clock. It sends data to one of the DACs, and it reads data from the ADCs. And using the I/O matrix, I hooked the I2S0 peripheral to the I2S1 peripheral down here in slave mode. So it now gets all its clocks internally without using any I/O. And then it's not listening to any outside peripherals. It's just sending data out to another digital analog converter to drive the speaker. So this one is a dual digital analog converter, one for each side of the headphones. And this is one channel with another dual back to drive the speaker. And I happen to be using readily available Texas Instrument devices. I'm using the 1808 for the A to Bs. It's 2 channels, 24 bits. They'll run just about any speed you want, up to about 300 and some thousand samples per second. You can buy them on a little breakout board for $8, or you can buy the part itself from DigiKey for $3. And the digital analog converters, I'm using the 5102s. Those are also each 2 channel, 24 bits. The breakout boards, depending on where you get them, $6 to $13. And DigiKey sells the part itself for $7. So those are the hardware parts. And this is how you set up a task. Actually, I'm sorry, this is what in regular C is called the main program. And in the DSP IDF, they, instead of using the word main, for some reason, they have this special function called app main. That's your main program. The only thing this program does is start tasks. And it's pretty easy to start a task. It's just this command, which has a little structure that it uses. There's only 7 parameters, most of which are the default parameters. Basically, you give it a name, you give it a name that you want it to use when it prints error messages, you give it some memory to work with, and down here you tell it which core of the processor you want it to operate on. So that's all you have to do. There's a second statement for the what I call the display task. I didn't type it out there, but that's all that you put in the main program. And then you have to have a while loop that runs forever that basically keeps this from doing anything else. to get, all it does is start the other two tasks. And you actually either let it run forever doing nothing. This keeps it from taking very much current up. Every second it wakes up and says, oh, go back to sleep. There's also another command which I didn't use that basically kills the main task. That didn't seem like the right thing to do, so I never actually tried that, but it is available. Now this is a very a task that has a fixed amount of work to do that has to get done in a defined time. So this is one of the tasks. And this is the CW Filter task. It's kind of find all your variables that are going to be in the scope in this part of the program, with all your structures that you want to use. And then before you start work, you basically set an alarm clock. You go out and you read a very accurate time from the operating system and put it in this variable. That's all that this line right here does. And then you go into a while loop. In this while loop, which is going to run forever, you do a very defined amount of processing. And in this particular case, I process 4 milliseconds of audio. And I send display information to the display task. Everything has to get done in less than 4 milliseconds. When it gets that work done, it calls this little command, or a function, I guess. And it says, based on the time that we started, in the period of, in my case, 4 milliseconds, 4 milliseconds after I started before, I have to start again. And this is what allows real-time processing, because this keeps this thing that starts exactly 4 milliseconds after the previous run. And hardware has collected exactly 48 samples. And every time it wakes up, it's got 48 samples to process, 48 samples to output, then it's done. And that's kind of the schematic diagram of how you do real-time processing. The display functions are not quite so real-time. I don't really care if the display gets updated at exactly the same amount of time each time. So what this also has got up to 4 milliseconds of time that it can use, and it restarts every 4 milliseconds. But in this while loop, just do a very small piece of the work, and then I check to see if I've used up 3 milliseconds. Of course, these FFTs take a lot of time. They're pretty calculation intensive. So I just do a little bit of the FFT and check to see if I'm out of time. And so this is how you handle big tasks that can't be done in a well-defined period of time. You break them up into little pieces, see if you're out of time. If you're not out of time, go back and do another little piece. When you're out of time, you can either start working again, or you could actually give the processor back until the next epoch, basically next 4 millisecond epoch, and start over. So when you start looking at the ESP documentation, it's kind of confusing, but the thing to remember is that almost everything in this processor is configured by setting values and structures. And these structures are defined in header files that you can find. at a lower level, which you can also kind of get your hands on, all of these structures get turned into 32-bit UINTs, 32-bit unsigned integers that actually drive the hardware. Problem with trying to write to those directly, as I found, is that there are overhead functions going on in the operating system that are writing to those. So you can go in and try to write them yourself. Come back, you're going to find that your ideas have been overwritten. So basically, you set some values in a structure and call a function. The operating system goes off and runs hardware for you. There are lots of YouTube videos out there of people talking about stuff. And you can usually find good advice out there. You can also find bad advice.
I find the bad one.
Yeah, I found a few bad ones also. I found people making very firm statements about things that the ESP32 doesn't do, but then you can find somebody else who says, "Oh, sure it does." So it's all in there someplace. So this is just a sort of a code example of setting up a I/O pin. This is the structure for setting up an I/O pin, and if anybody's done any Arduino work, it's not all that different. But in this case, you can give the pin a name. You have to use you have to put some code that is defined in the header in there, which just says, this is how I set the hardware pin. This is a selection of whether it's an input or an output or both. You can control the pull-up resistors. They also have a pull-down resistor. So it's not very different than what people may have seen in simpler processors. And then you just say, all this really does is say configure the pin, and that's it. And almost all the other peripherals and things in there are done in a similar manner. You set up a structure with a bunch of options and say go do it. And that's about all you do. We've got a bunch of backup slides. Greg, do we have time for any more? Or I've got some backup slides to show various features.
Yeah, I would show your pictures of what your end, what you're going to try to. Oh, it's in the bottom left here.
Well, this is the analog version of the
okay.
box. That's hooked to the S line now, so that's my S line operating position with the original analog filter. The next version probably won't look exactly like that, but it'll look something like that. So this is the oscilloscope display. I'm looking at a 20 millimeter CW signal. Up here in the amplitude, I don't know if you guys see the, I'll just draw arrows here.
Yeah, we see the little dot.
This is about, the scale for this is 10 dB per divisions. So and you see that it's real even up here at the top. That means we're in AGC. The AGC is keeping the output level very, and that's the AGC of the radio, is keeping the output level very constant. You can see that in this case, we have some QSB, and it's kind of amazing how many HF signals have pretty severe QSB. Another feature you can see here on the FFTs is you can see the FFT, this is 50 hertz per division. horizontally. So we've got a 400 hertz filter in the receiver. You can kind of see that here. And we've got a 100 hertz filter in the filter. So this is actually two FFTs laid on top of each other. The narrow bars are for the input FFT, what's coming from the receiver. And then the kind of thicker bars are what's coming out of the narrowband filter.
Interesting.
See that we're pretty close to tuned to right on here, and kind of get some idea how the signal noise ratio is, because this is also 10 dB per division here. And this is a rolling display. This is current time, and this is history. So if you look real careful, you can actually read the call sign from a club station up in Canada that was on there the other day. It's there's a V A2 R A C, and then you start it over. So you can actually, if the guy's sending fairly slow, you can actually read the code there.
Very nice.
This is a little stronger.
Yeah, that is
signal.
cool.
And, see just a little bit of QSB, not very much. It's pretty darn good signal there. Got a narrower filter for the CW filter. Is also on frequency. And this is the radio. The radio is in CW mode, tuned to 100 hertz above WWV. This is WWV's carrier right here. These are the 100 hertz sidebands for WWV. It sends a coded time signal. And it's amplitude modulated on this 100 hertz. So this long chunk of larger signal is what they call a position pulse. These are logic zeros in the binary time code, and that's a logic 1. The time scale across here is 4 seconds. So it's about 400 milliseconds per division. And they call it their pulse, their position pulse is pretty close to 800 milliseconds long. The 1 bit is quite a bit longer than a 0 bit. When I talked about these signal noise ratios here, I had forgotten that the sidebands, when they're considered a logic 1, they're about 15 dB below the carrier, and when they're a logic 0, when they're off, they're 30 dB below the carrier, so they don't completely go away. This is low states. Those are some noise, and some of the carrier gets a very low level. Now, you CW guys probably don't know what FT8 is, but it's a low data rate transmission. Here we've switched this display over to be reading out frequency, and it's mainly as a tuning aid is what I did it for. But in this case, you can actually see the different at FT8. This is I can't remember Frank's last name, but this is the FT is the name of the professor who invented the waveform. And 8 stands for 8 area FSK. They have 8 different tones they switch between. So you can see the different frequencies here. If you look real carefully, you can actually see 8 different frequencies going on. This was a very strong FT8 signal on 20 meters. You can see that there were other guys transmitting in that time slot, which is always the case in FT8, I guess. The fast flow array transforms, I take 512 samples at 4,000 samples per second. If you're familiar with windowing, I apply the Blackman-Harris window, and that just makes it look a little better, basically. But I can resolve tones that are about 8 hertz apart. So that's what we write to the display there. And I think that's probably enough detail. Oh, the circuit card itself is a 4.5 by 4.5 inch card. It's laid out in KiCad with the schematic and the board layout. So if you're an old time Gollums guy, you know, we used to do a lot of breadboards. You buy the breadboard in the parts store there, sort of a standard 56 pin connector. Well, I got a bunch of those connectors off of eBay a few years ago, so that's what I do some more projects with. Most of the parts are surface mount, parts on both sides of the board. Most of the back of the board is ground, and most of the parts that have one grounded lead are on the back of the board. That's just a layout standard that I have. I used a lot of different voltage regulators because I didn't know how much trouble I was going to have with noise. So there are 38 pins on this DSP 32, and a lot of them are not really available for use. For some reason, they bring out a lot of memory lines that aren't too useful for projects. So between the front panel and all the control lines to the radio, I've pretty much used up all the audio that and the ITS stuff. Okay, we won't go through any more code. Nobody can stand that. We'll go back and show the picture of the board, I guess. That's what the board. The board's got some bypass relays, so if the power's off, the radio still works. It's got a big speaker amplifier, and then just a little bit of analog circuitry to get low level signals in and out, and lots of voltage regulators. That's what you're looking at on the board.
Dave,
So I'll take any questions, and
Dave,
Greg can tell us when we're done.
hey, on this connector, this edge connector, is that something you use on all your projects?
I've used it on several of them, mainly because I used to buy scrap breadboards from the surplus store, and I'm not quite out of those yet.
Okay. Well, I was, because I've seen that, I think, on a couple of your projects. So I was just wondering if that was a standard way of your building.
Well, when I needed that much I/O, yes. I also use just the these 10th inch headers. Let's see if I can show you the breadboard.
Yeah, I've used those headers too. Yeah.
Okay, so you guys have seen those. Those are just 10th inch headers used in connectors.
Right.
Wire from an add-on board down to the old audio card, the analog audio card. That's
Okay. Yep. Thank you.
Any other questions? Oh, so this is sort of an advertisement for the ESP32. It is possible to do things with it. I think I've seen some pictures flashing up here. I'm not the only guy who's tried it.
I haven't done anything with the IDE that you have. Mainly everything I use is the visual environment or Arduino environment, but I've looked into trying to learn that. That's quite a task to learn the IDE. But yeah, you get a lot more functionality, and you can drive the 2 cores and stuff like that. So yeah, nice.
Well, the more I look out on the internet, the more I think you can probably do anything you want on the Arduino IDE also. I saw people saying you couldn't, and I believed it. But the more I look out there, people are figuring out how to do it. Almost everything is available.
Well, thank you, Dave. If you send me the presentation, I can put it up on Groups.io and people can get it from there too.
Okay.
If
very
you
good.
want.
I'll talk to you and we'll figure out how to do that.
Okay. Any other questions for Dave? We'll close the meeting.
Excellent presentation. Thank you, Bryce and Greg, for covering for me. I had a customer meeting today, and thank you, Dave, for stepping up.
Quite welcome. My pleasure.
It was
Yeah.
excellent presentation. So I look forward to going through the slides.
Let's see, how do I give this back?
Well,
You just go to unshare. I think there's up on your control panel. I think it says stop share, I believe.
well, I think, George, you're free to close out the meeting if you want.
I don't know if I thought Bryce had the controls.
Okay, whoever has the control.
Bryce, take the controls, close us out. Thank you, guys. I really appreciate
right.
everybody's help. Take care.
Bye-bye.
Yep.
Bye-bye.
Appreciate everyone attending. We'll talk to you later. Bye.